Okay, so now we'll do preparation of alcohols. How to prepare alcohols? Okay, first method is by hydrolysis of haloalkanes. By hydrolysis of haloalkanes. So when you go with the hydrolysis of haloalkanes, you see what happens is that suppose there is a haloalkane. The general representation of haloalkane is Rx. Okay, R is an alkyl group, X is a halogen. Plus the general representation of plus if you treat it with KOH in aqueous form, you will get ROH plus KX. See, so if you write this C2H5Br plus KOH if you do at aqueous state, definitely if this R comes with the OH, then this R, which is the alkyl group, C2H5 will come with OH and KBr will be produced. You can do this with working potassium hydroxide. You can also silver hydroxide. Like for example, C2H5Br, you can end up with DOH or treat it C2H and HBA. So if you notice this reaction, this is ethanol. Okay, let me see more reactions are there or not. Okay. Now you see, primary alkyl halides give good yield of alcohol. So always remember, primary alkyl halides gives okay. Primary alkyl halides give good yield of, remember this, yield of alcohols. However, 3-degree alkyl halides will give alkene, will give rise to dehydrogenase. See, does this sentence? For example, you take CH3 Br. Now functional group linked to the C more, so carbon. So I take this alkyl halide, okay, if I take a primary alkyl, right, 3 Br, that or you can take 3 CH, that case means the bromine carbon is attached to one carbon. Are you getting? So that what I can say, primary, if you treat away, then what expect that on CH3OH, or you get CH3 CH2OH, and yes, you will PR KB. But in this case, if you expect that, okay, CH3, I will write that I will get this one, means here OH will come and go out. Expect that no, kind of one. C double bond to, so double bonded to, sorry, CH2 double bond is, and single bond CH3 and one CH3. So what here? Let's get you get we primary good yield alcohols fine giving good yield of alcohols. Yeah, but the tertiary alkalides, however, the tertiary alkalides will give rise to alkene due to halogen here. Let us try to understand. You see, here if you carefully, I will show you. Let me show you this reaction in the next page. Suppose it was like this, no? CH3 H3. When you get KOH, this come here, fine. That OH come here. CH3 3. What you are expecting? But what is happening is from here, one H of CH3 will be with this and go, and this is happening in tertiary alkalides. Okay, it will be happen. These two, this bond will shift, make a double bond here. If O takes away the H away, this bond will shift and make H2 test CH3 only. Sorry, double bond. So this compound you have yes or no? And you have also obtained a you have also obtained a H2O. See here also see that liberated. Understood? So this is what happens in case of this is you have to remember that this is what happens in tertiary alkalides. Obviously is arising and then what secondary alkalides. Just hold on, I'll just move the page. Okay. Now arises that what happens in case of secondary alkalides. Let us try to understand what happens in case of secondary. So if I draw a secondary alkali CH3 and here if I give a bar, you will get a mixture of tertiary alkali बिल्कुल भी अल्कोहल नहीं। तो मैं यहाँ उठाया, क्या हुआ था, ये वही चार यहाँ पे आके लगा कि अभी तो एक ही चीज को लेके चला जाए, फॉर्मेशन राइट। और अल्काइल हैलाइड मेरे को देख, लेकिन ये जो सेकेंडरी अल्काइल हैलाइड है ये जब करेगा तब NaOH KOH के जगह NaOH ले हो, तो आप एक्सपेक्ट कर रहे हो कि ये आएगा, राइट और रॉन्ग, जिसके और NaBr ऐसा बात नहीं, NaBr निकल के चला जाएगा with only 50% of the with it another 50 CH bonded to CH। ये यहाँ पे जब घुसा हो तो कंपाउंड CH ऐसा है, यहाँ पे जब OH आया होगा तो CH और ये H निकल, तो यानी H2O है। गेटिंग पॉइंट। चलिए बेसिकली मेरा बोलने का पॉइंट ये है कि आप अगर ट्रीट से एक हाइड्रोक्स से एक एल्कालाइड तो उसका हाइड्रोक्स हो जाएगा। केस में एक्स है के चला और उसके जगह चला आएगा, जैसे यहाँ पे हुआ है ROH प्लस के। ठीक है, तो अब क्या हो रहा है यहाँ पे C2H5Br प्लस OH क्या हो रहा है कि नहीं, K Br के साथ चला गया, OH के साथ Ag और H5 ये प्राइमरी में टर्शियरी ऐसा नहीं, जब OH घूमने लगेगा H2O जाएगा और CF प्रोडक्ट फॉर्म होगा अल्कोहल में। सेकेंडरी में क्या 50 ये कंपाउंड होगा, 50% ये कंपाउंड पर के लिए हो रहा है, वो सेकेंडरी जो प्राइमरी अल्कोहल के लिए होगा वो भी सेकेंडरी। ओके, और डिहाइड्रोहैलोजिन का बता दिया है क्या होता है, अगर OH जैसा एक और ओपन के और के बीच डबल बॉन्ड फॉर्मेशन जाता है। इस अंडर वेरी फॉर देखिए एल्केन इज प्रिपेयर्ड फॉर अल्कोहल। अब याद आर prepared alcohols from haloalkane to reversible is less. Okay, so this is not widely used, but if I go to the hold on. If I can do the next thing, or go for phenol preparation. Phenol, no, sorry, phenol, but alcohols. Alcohols mean if I say, oh, this is a phenol, right? But if I say this is aromatic alcohol. So the difference between phenol is also obvious, is aromatic compound. But when we say aromatic alcohol, remember about substitute alcohol. Getting my point? So talking about substitute alcohols. So if you go for preparation, suppose you take CH3 plus Cl2 and heat it, and hence find CH2Cl, and there is release of HCl minus HCl, because here Cl bond is broken down, one Cl went to H, the other Cl attached. Difficult to know? Okay. Now treat it with aqueous KOH. Now treat it with aqueous KOH. What will happen? It will be CH2OH and plus will be so it is the same method as the method we have just learned, but just what we are doing, we are making this ring or making this compound vulnerable to this reaction. I mean, more competent towards this reaction by adding a Cl. Understood? So this is how alcohols are prepared and aromatic alcohols are prepared. I hope you have understood. Now we will go into the next thing. So second method is hydration of alkenes. If you do hydration of alkene, still you will get alcohol, okay, but you need H2SO4 for that. See, Suppose you take an alkene CH2 double bonded to CH2, right, and treat it with H2SO4. The H2SO4 should be concentrated H2SO4, and remember, concentrated H2SO4 breaks as H plus and HSO4 minus always, not as H2 plus or minus 2. It is concentrated, it will always break like this. Okay, so what will happen is this bond will be like this: CH single bonded to CH. Now it is CH2 double bonded to CH2 too. It will be like this: the double bond, this CH2 double bonded to CH2, right, and this single bond will break down. One pi bond will break down. When pi bond will break down, one bond will open here and one will open here. Now this will come here. Are you getting my point? Each will come. So we will get CH3, CH2, HSO4. Now when you do hydrolysis of it, this H2SO4, then you will the HSO4 will go, and then what will happen? A hydrolysis of doing means the H plus and O minus. Are you getting my point? So H2SO4 goes out, then it will be like CH3 CH2 OH. How this is happening? Now what is happening? Let me take this. CH3 CH2 HSO4 was there. This HSO4, okay, will go away the H to form H2SO4, and the OH will enter. As simple as that. Is this understandable? Is this clear? Okay. So I hope this thing is of. Let me give another example. Hold on for a second. Now you see. Suppose you take CH3 CH double bonded to CH. Fine. Now what will happen is that if you treat it with H2SO4, then again CH3 CH CH, this pi, and pipe break, and HSO4 will come. Okay, so bond is not that is required also. So this HSO4 will come and H will come. Okay, so what will happen is that you, sir, not HSO and H plus in this. So you have to go a little bit and of Nikov's and anti-Markov recovery. Okay, the one is number of hydrogen adds one portion, that is one of hydrogen. Okay. This you will know I have added HS. That is the point. It is part is kind of adds with the one which carries less number of hydrogen. Are you getting my point? So this happens. Now CH3, CHSO4, CH2, Chem. Now treat it with step in with what? Now what happened? 3 HSO4 OH होगा. So what? Teeth propane to wall or isopropyl alcohol. Are you getting my point? Is this understood? Always remember jar. You have to remember this rule. Through Markov's rule, you have to remember with whom H4 will add. Are you getting my point? And then you always have to remember for carbon contain less number of hydrogen. So for add H2 ওখান থেকে उसी जगह से HSO4 वहां चला. यहाँ पे भी ऐसा ही किया मैंने. तक नहीं H4 जहाँ पे था जिसके साथ था HSO4, ठीक है. यहाँ इलेक्ट्रिकल इससे मार्को एंटी मार्को का कोई इंपॉर्टेंस नहीं है. यहाँ से कोई बात नहीं है. सिमेट्रिक होने से अलग. तो मैंने वही किया. क्लियर? तो आई होप यू हैव understood. So this is the main thing. Now some reactive which really go under hydration. Here is what? Here at you have added the HSO4, then hydrolysis is of yes or no? Then there is hydrolysis with water. But some under direct hydration they undergo in presence of acids. Suppose for example CH3 C double bonded to CH2 CH3. Now if we to CH3 C CH3 CH3 OH. So what has happened? It has gone down. OH से आय खुले गए এখানে বের হচ্ছে ওখানে H2O প্লাস এর OH এর মধ্যে এক দিচ্ছে এখানে একজন. Got my point? Understood? Okay. This is one of good method of manufacturing of alcohols. Okay. Now moving forward, let me turn the page. Okay. Preparation of alcohols. From and ketones to give, this is the number third method, to give alcohols, ketones to give in presence of preparation of alcohols, aldehydes and ketones in presence of agent. Grignard reagent, what you have to do, you have to treat your aldehyde or ketone with a Grignard reagent, and hence an intermediate will form which will give rise to primary, secondary or tertiary alcohols on reduction. Means, suppose you take a aldehyde or treat it with Grignard reagent, you will get an intermediate. Intermediate, if you treat with acid, that intermediate, if you treat with, you will get alcohol. Okay. Now, fact is this: you take HCHO. HCHO is what? Methanal, right? It is an aldehyde or formaldehyde. Notice what happens. HCHO can be written as C double bond O H. This is the what group? Aldehyde group, and H. Fine. Now treat it with Grignard reagent. Grignard reagent is what? Think alkanes are also about Grignard reagent. Grignard reagent is CH3 MgBr or CH3 RMgX. RMgX. मैग्नीशियम मक्खन रहेगा ही, भी अल्काइन रह सकता है, सॉरी भी क्या बोलते हैं इसको, हैलोजन ग्रुप रह सकता है. मीन्स C2H5Mg these also Grignard reagent. Okay. CH3M more CH3MgBr. Treat with Grignard reagent. Now what you will get is, you will get intermediate. This H will be in its place. This H will be in its place. This double bond will break, single bond, and this will come down. Here you will get breakage. You will get OMgBr, and here you get C. This is the intermediate. Understood? Yes. Now treat it with acid in presence of water, aqueous. Then what you will get is, you will get first you will get MgOH. So if you get MgOHBr, and the other one you will get is CH3 CH2OH. So CH2, here you will get OH. This C, this C. Understood? This C is this one, and CH2, and here you get a OH and MgOHBr. So here you get the alcohol. This is a what kind of alcohol? Primary alcohol or a tertiary alcohol or a secondary alcohol? This is definitely a primary alcohol. Now you want to see one thing interesting. Just keep in mind that this is primary alcohol. Yeah, it is primary alcohol. Now let me go ahead. Let me treat CH3CHO. This is what? Ethanal. This is also an aldehyde. C double bond O CH3H. Treat it with a Grignard reagent CH3MgBr, and now you treat it with a Grignard reagent. So what is the result you will get? C, H will be in its place. Will be O. Here one will break. This one will come here. MgBr. This CS will come here. So and will get CH3 C H CH3 OH. or no? Kind of alcohol is secondary because the carbon is attached to the functional group is attached to two more carbon atoms. Another more interesting. Treat with an 3 E double bond 3 ketone with CS A B. You will get is C C CH3 C O, this single bond O will break, this CH3 will become OMgBr. Now treat it with an acid in the presence of H2, you will get CH C CH3 CH3 OH. This is a tertiary alcohol. Now you can see that if you use a ketone, you will always get a tertiary alcohol. Justification, because MgBr will attack here and one will break down and the C of the Greek region will come here. Ketone already, if in this carbon it is going to become OH, already it is secondary. If in the another bond a CH3 comes, it will always become tertiary. Now if you want to increase the carbon number, what you will do? Suppose you want to increase the carbon number. Where? No. Yes, obviously, but you take a Grignard reagent which is carrying more C. Don't you think that? Because then there will be more number of carbon coming here. In that way you can increase. But still it will always remain a tertiary alcohol. So with a ketone, always you will obtain what? Ketone. And with an aldehyde, you will obviously always obtain a secondary one, right? Because with an aldehyde, it will always be like CH3, CH2, CHO, suppose. Still, if you use this, C double bond O, one CH, this will be CH3, CH2 group, yes or no? Now, big attack here, like here, MOMgBr, and this CH3 has come down. So already यहाँ पे अगर खुल के एक C वाला आ जाए तो इसके साथ अगर इसी कार्बन के साथ अगर फॉर्म और यहाँ पे C वाला कुछ आ जाए, जैसे यहाँ पे CH3 था यहाँ पे आ गया, तो ऑब्वियसली फॉर्म करेगा. तो प्राइमरी अल्कोहल कहाँ से मिलेगा? रखना सिर्फ और सिर्फ मिथानॉल ही प्राइमरी अल्कोहल दे सकता है. क्यों? मिथानॉल हाइड्रोजन अगर और चेन, लेकिन ये दोनों तो हाइड्रोजन के साथ ही लिंक होगा. आया ये चीज समझ में कि नहीं आया? समझ में आया? करना होता है थोड़ा इतना, कहाँ से क्या जाता है उतना समझ में आएगा. ठीक है, यहाँ पे